So hello guys, welcome to one more new live stream. Today we are gonna review and discuss the Leetcode weekly contest 436, which happened just like 20 minutes ago, which got over just 20 minutes ago. So guys, how are you all doing? How many of you in the chat gave the contest today? So guys, did any of you give the contest today? How was the contest? I personally felt none of the codes were long today. It was an easy contest. All were like 10 to 12 lines of code, maximum 15 lines. So guys, with this we are gonna start our first question of the day. The first question is sort matrix by diagonals. You are given with an n cross n square matrix of integers grid. Return the matrix such that the diagonals in the bottom left triangle including the middle diagonal, are sorted in non-increasing order. The diagonals in the top right are sorted in non-decreasing order. So they have given an example here, 173,982,456. We have to sort it in such a way that the triangles in the bottom left. So the bottom left is this 186,945. This should be in the order of non-increasing order. Non-increasing in the sense decreasing order. The diagonals in the top right, 732. These should be in the non-decreasing order, which means they should be in the increasing order. So 173,982,456, it will get changed to 823,967,451. So what are the constraints, guys? We'll see the constraints first. The length of the grid is equal to grid of I dot length is equal to n, and n is lesser than 10, and grid I and j is equal to 10 raised to maximum 10 raised to 5 and minimum minus 10 raised to 5. So grid of ij is in the range minus 10 power 5 to 10 power 5. So with this we are gonna start. We'll see what is the question first. We are gonna see what was the question there. First thing, a matrix n cross n. N cross n matrix is given, guys. So first one, it should be sorted in non-increasing. What was the question? Non-increasing and non-decreasing. So the bottom, second one is top. Bottom triangle, top triangle. This includes center. It includes the diagonal. Okay, right. Just a second, guys. So the bottom triangle, it includes the diagonal. So the bottom triangle, it should be ordered in descending. The top triangle should be sorted in ascending order. That's all is the question. The top triangle should be sorted in the ascending order and the bottom triangle should be sorted in the descending order. The bottom triangle includes the the bottom triangle includes the diagonal given. So now we'll see how to solve this question. First thing, what is gonna be our intuition for solving this? Intuition, guys. So this is how we are gonna do this. The intuition for this question is gonna be we have to sort sort the diagonals in a given way. So for this, the first one is what is the first point given? Bottom left. Bottom left plus diagonal. Bottom left plus diagonal. We have to sort it in non-increasing, which means decreasing, descending. The second one, top right. Top right. What about top right in the ascending order? So this is our intuition basically, sorting the diagonals in the given way. Now we'll see what is the approach we can use. So guys, this question can be solved in two ways. I'm gonna use the other way. You can also solve this question using selection sort. Anyone in the chat can come up with the idea how it can be solved using selection sort. I'm gonna tell you the other approach, how it can be solved. Now, anyone in the chat, how can this be solved? Anyone who knows how we can solve this question? Come on, guys, try. How can this question be solved? Any method works. Anyone in the chat, guys, how this question can be solved? Okay, so we'll see how we can solve this question. The first step is hmm, this is our approach. Okay, so the first step we have to store the diagonal elements by diagonal. This is our first step. Now, ask how to do this, guys. We'll do this with the use of dictionary, default dict, which is already an inbuilt package in Python. We'll use a dictionary with value I to j. The given value will be list. It will be a list of elements belonging to that diagonal. So it's done. Now this is after this, we have to iterate through the matrix and group elements into the corresponding diagonal list. Diagonal lists. Now, this is our first step in the approach. We have to store the elements by diagonal in a dictionary of ij, and we have this will be getting as a list of elements and of the diagonals. Then we have to iterate through the matrix, group the elements. We have to group the elements into their corresponding diagonals. Now, anyone in the chat, after this, what is our main next main step? So first step is over. No, the second step. The second step is anyone in the chat, guys, what is the second step? Sort the diagonals. Okay, guys. Now, how we are gonna sort this? If we have if the diagonal index, we will take diagonal as diagonal di, index is I minus j. What is I minus j? I minus j is row index minus the column index, because every element in the matrix At position I comma j, it will belong to a diagonal. It will be uniquely identified by I minus j. Now, so we have made this non-negative. This I minus j is non-negative, which includes all the positive values. Then we are gonna sort the diagonal in non-increasing order. And if it is negative, we are gonna sort it in non-decreasing order. Now guys, after this, what we are gonna do is we have to give the output as a matrix itself. So what are we gonna do here? Third step, we'll refill the matrix. Refill the matrix. We'll refill the matrix now. So this is done. After we in the refilling of the matrix, what we'll do is we'll use another one another dictionary. We'll index it to track the position of elements, track position. We'll track the position of elements while replacing them in matrix. While replacing in matrix. While replacing them in matrix. Now, the second thing, we'll iterate through the matrix again. Iterate through matrix again. Again. For this, what we are going to do is we'll place we'll place the sorry guys. We'll place the sorted elements. We'll place the sorted elements from diagonals. So with this, we are going to end our approach. This is what is our approach. That's all basically. Nothing much here. Very simple approach and a very simple question. But since it's a matrix question, people tend to confuse it very easily. So now guys, anyone has any doubts in this? We'll go to the code. Thanks Shanmukesh. Thank you for your support. So guys, here first we'll go to the code. Here's a code. Now to understand it better, we are gonna add our comments for the code. What is gonna be the code? This is all importing the default dictionary and all, storing the elements in the each diagonal. So the first part is just initializing stuff. We'll just leave it all the initializing and taking the variable part. Now the first for loop, it is for grouping elements by index I minus j. Then index or key. This is also called key, which is equal to I minus j. Now, after this is a step 1. Step 1. Now here, this is sorting each element, sorry, sorting each diagonal. This is our step 2. This is gonna be a step 2, sorting each of the diagonals. If di greater than 0, this is for the bottom triangle, including main, bottom left, including main diagonal. And this is for the other one, top right. Now, for I in range n, for j in range n, this is our step 3 now. I'll just go for a gap. This is our step 3, placing sorted elements in matrix again. So this is our step 3. This is our step 3, guys. For this first one, what we are gonna do is we'll take a for loop in range n, then nums of I comma j is equal to diagonals I minus j, index of I minus j. Now, here, finally, index I minus j plus equal to 1, which is just plus plus, nothing much. Why are we using this? This is to move to next element in diagonal. There's a final step and we'll return the nums value. Now we'll run this code and check if it works. It runs for the given shown test cases. Now we are gonna submit it and check if it works. So this code works perfectly. We can submit it again if anyone has any doubts. So guys, you can see that this code works perfectly well. Now we'll go back to our question. We'll go back to our writing page. What are the time complexity? What is the time complexity and what is the space complexity of this question or whatever this code? So guys, there's a hint for time complexity. It's a matrix with two loops I and j. This is the hint. So come on guys, anyone in the chat, what is the time complexity? Anyone in the chat? We'll see what is the time complexity now. The time complexity for collecting the elements will be O of n square, two loops, I and j. Now, for sorting each diagonal, the time complexity is gonna be O of n log n. O of n log n. O of n square, collect, it is to collect, n log n is to sort diagonal. So as to sort diagonal, it's taking off n log n. And after that, to put the elements back, sorry, not bank. To put the elements back, it's again gonna take off n square, elements back. Now, what is the overall time complexity of this? This is gonna be anyone in the chat. O n square, O n log n, and O n square. What is gonna be its time complexity? The time complexity is gonna be O of n square log n. So guys, here, and this is dominated by sorting. This is not equal to O of n square. It's not equal to O of n square. It's actually greater than O of n square. Now, after this, what is the space complexity of this? Space complexity of this is gonna be O of n square to store diagonals to store the diagonals and O of n for indexing dictionary. Index dictionary. So this means the overall space complexity is gonna be O of n square, and the overall time complexity is O of n square log n, which is strictly greater than O of n square. Is the first question clear, chat? Is the first question clear, chat? Anyone has any doubts in this? I hope it is clear for everyone, guys. The first question. Is the first question clear, guys? Okay, I guess the first question is clear. We'll go to our second question. What is our second question? Assign elements to group with constraints. We are given with integer array groups, where groups of I represent the size of ith group. We are also given an integer array elements. Your task is to assign one element. Your task is to assign one element to each group based on the following rules. An element J can be assigned to a group I if group I is divisible by I elements by elements of J. If there is multiple elements that can be assigned, then we have to assign the element with the smallest index J. If no element satisfied, we have to assign -1 to that group. Now, we have to return the integer array assigned, where assigned I is the index of element chosen for group I, or -1 if no suitable element exists. Note, a very important point here, an element may be assigned to more than one group. Now, groups 0, 4, 3, 2, 4, elements 4 and 2. Now, 0, element 0, which is 4, it can be assigned to group 0, 1, and 4. Now, the output is gonna be element 1 can be assigned to group 3. So, the output now is gonna be 0, 0, -1, 1, 0. Now, after this, we'll see the constraints. The given constraints here are group length is in the range 1 greater than equal to 1 to 10 power 5. Elements dot length of elements is in the range 1 to 10 power 5 both included. Groups of I, indexing of groups is also in the same range 1 to 10 power 5 including both. Elements of I, like the indexing of elements is also in the same range 1 to 10 power 5. Now guys, we'll go to the solving of the question. We'll go to our question 2. Question 2. So our question 2 guys, we'll go to our question 2. Anyone, what is gonna be our intuition or approach to solve this question? Anyone in the chat, what is gonna be the approach and intuition to solve this question? Come on, chat, anyone? Okay, so we'll continue this, guys. I'll only say that the intuition is that assign elements assign the elements to groups based on given condition. That also, if repetition is there, prioritize the smallest index. So guys, this is a simple intuition. I won't complicate it. This is what is uh, where we are asked to do. Now, what we'll do? First thing, we'll go for our approach. Approach, guys. Anyone, what can be the approach? First step, It's actually simpler than the first question, honestly. So here basically in the first step, we're gonna pre-process it. Pre-process. What are we gonna do here? We'll create a dictionary. Create dictionary. Name of the dictionary which I took here is num index. What this will do is this will store first occurrence. First occurrence means the smallest index. It will store the smallest index of unique elements. So this is a pre-process. A very simple thing. We'll create a dictionary of num index and it will store the first occurrence of the smallest or the smallest element in the elements. Elements is the given array. Now we'll go to our second step. What is gonna be our second step? The second step is we have to find best element. We have to find best element for each group. We have to find best element for each group. So for this, what are we gonna do to find the best element? For this, the first thing, this is a very important step, guys. So be care, listen to this carefully. First thing is very common thing. Iterate, iterate over the given each number in the groups. Iterate over each number in the groups. In the second step, what are we gonna do? We'll use divide function. Divide function to find smallest index. Why are we using this? Smallest index. Find the smallest index. So I guess it's clear till now. Now, after this, here within this point, we have one more point, which is we'll iterate through the potential devices. Iterate through devices, through devices, iterate through devices from 1 to square root of group. I'll just write grp for group and have space to write it. Now, after this, what we'll do? If divisor, if divisor is I, we have to check if it's I or is in num index. Check I is in num index. Our dictionary. This is the name of our dictionary. Sorry, this is the name of our dictionary. So we'll check. Then after this, the third step, the very important and the last step, we'll keep the track of, we'll keep the track of, we'll keep the track of minimum index. Min index. After this, the final step of this one, the fourth step, we'll write it. If sorry, we'll write within this point. No issues. We'll write within this point. A very important thing. If none matches, no divisor matches. If if it has no pair left. If no if it's the only one, like nothing is there with it. If there's no match. Basically it's a single on the Valentine's week. For a single on Valentine's week, we'll return -1. So guys, here it is. For all the singles in Valentine's week, we are gonna return our -1, guys. Now, after this, the final step here. What is the final step, guys? We have to return the result array. Very easy thing. How many of you feel this is easier than that matrix question? Honestly, from my opinion, this is easier than the matrix question. So, chat. After this, now we'll go to the code. So, we'll bring the code. Here is our code. Now, for better understanding, we are going to add the comments for this code. The first part up to here is just declaration. After this, the first for loop. I'll just give a space after this. The first for loop is for pre-processing. I'll just write pre-process to find smallest of each element. Now after this, we'll make a function divide. So what are we gonna do here? Smallest index is divided. The smallest index is divided. Sorry. This is to find the smallest index that divides num. For this, we are gonna declare the largest number for upper bound. To avoid data overflow. Now for this, we'll run the first for loop to iterate up up to what we are gonna iterate this, guys. I said it while explaining. Iterate till square root of num. Now here here check we are gonna check the divisor and after that we are gonna check the pair we are gonna check the pair divisor which is num divided by I. After this, if no element form, this is the single and Valentine's week. For all the singles in Valentine's week, single in Valentine's week will return -1. Now, after this, what are we gonna do? We have to assign for the groups, right? So for this, assign element for the group for each of the group for each group actually. This is now we are gonna return the result. This is basically the result array. Now we are gonna run this to check if it works. So this works perfectly. Now we are gonna submit it to check if it works in the hidden cases as well. And this code works perfectly well for all the given test cases. So now chat, if anyone says that this is gonna be a bit difficult question, but what is the time complexity for this question? Anyone in the chat, if you are gonna answer this, I'm gonna pin your name in the comments. What is gonna be the time complexity, guys? If anyone answers this, I'm gonna pin you in the chat. If anyone answers, what is the time complexity of this? Here is the code, showing you the code also, showing you the question as well. If you answer it correctly, I'm gonna pin you to the chat section. Come on, chat. We'll see. I'll give 1 minute time. Come on, chat. Let's go. Right? Mm, Shanmukesh says it's O of n square. We'll see. Good try. Or n log n. We'll see. Chat says, good try, Shanmukesh. O of m square or O of n log n. We'll see. Good try. Anyone else in the chat? Here's what is the answer given by the chat. Any other answers in the chat? You'll be pinned for the comment section, guys. There are 5 people watching. Come on, guys. Right. I'll give you a hint also. This is wrong actually. It's fine. This is wrong. Well tried. It's wrong. Now I'll give you a hint. Now try it. Time complexity. For pre-processing. For pre-processing, We'll take length of elements is equal to m. Okay, and this is the step one. This is a step one, and the step two is finding devices. Finding devices. Now try chat. I have given you the hint. Try it chat once. It's easy now. I have given the hints. So, okay, I'm gonna answer it now. The pre-processing is gonna take O of M, and now we'll come for the finding devices step. That's the most important thing here. Now we'll see worst case. We'll first write worst case. Worst case. Worst case, what is gonna be its time complexity? For finding devices, it's gonna be O of root n. And for the best and average time complexity, like this is gonna result. What is this gonna result for us? N equals length of groups. N equals length of groups. So here k is the max possible value. K is the max possible value. K is the most possible value. So this is gonna be O of n into root k. Now the final time complexity for this is gonna be time complexity for worst case, for best and average case. So for the worst case is when we have a Valentine single in every every element is a single in Valentine's week. That's the worst case, guys. O of m plus n root k, and best and average is gonna be O of n root k. Now, what is the space complexity? Space complexity is very easy, so I'm not even gonna ask. Everyone in the chat will easily say M is the space taken for storing. So it's very easy. The space complexity is O of M here, and O of 1 for additional space. Additional space beyond result array. Beyond result array. I'll just write the array symbol here. So O of M plus O of 1, which is gonna result for us in O of M. So it's clear. I hope it's clear, chat. Everyone in the chat, guys, is it clear? I guess it should be clear for everyone, guys. With this, I guess everyone are clear with the second question. We are gonna jump into our third question. Any doubts, chat, before that? Okay. So we are gonna jump into our third question, and it's marked hard. We'll see how hard it is and how easily we'll decode it. What is this? A substring question, basically. I guess you all are aware of what substring means. It's a contiguous, non-empty sequence of characters within a string. For example, if substring is a string, okay, if number is a string, then num is a substring. And now we'll come to the given question. Count substrings divisible by last digit. Okay, you're given with a string S consists of digits. So it's a string which contains only digits, guys. We'll see. Return the number of substrings S divisible by non-zero last digit. A substring, it's the definition of substring. It says that a substring may contain leading zeros. So what do they mean by this? It means it might have zeros in the starting. It can be 0, 0, 1, 2, 3. So now we'll see what is the thing. We'll just smaller. Okay, let it be. The given S is equal to 12936. According to them, according to this, there are 15 substrings in total. So guys, there are 15 substrings. What is the formula to find number of substrings, guys? Anyone in the chat? What a simple formula. If there is a string of length n, if there is a string of length n, what is the formula to find the number of substrings, the total number of substrings? Leave all the other stuff. The total number of substrings. Anyone in the chat, guys? What is gonna be the number of substrings formula? What is gonna be the number of substrings formula in a given string? Number of strings in a given number of substrings in a given string. Okay. So guys, Shanmukh is well tried, but I'll just say what is the difference now? Number of substrings. We'll go to this question first. Third question. Now, substrings I asked. Substrings. Substrings should be ordered, right? Contiguous part. What you gave us subsequences. But well tried. Nice you are responding. It's a good thing. Yeah. Now you are right. Now you are absolutely right. 2 power n is gonna give us subsequences. Subsequences. But for substrings, the formula is n into n plus 1 by 2, which is gonna give us the number of substrings. Yeah, you're obvious. You're 100% correct. Shanmukesh. Nice. Great answer. No. There are 5 elements in the first string in the given example. What are those 5 strings in the given example here? 12936. 12936. With this, the total number of substring possible is okay, 5 digit number. So 5 into 6 by 2. 5 into 6 divided by 2, which is equal to 30 by 2, which is equal to 15. And in this 15, there are 4 such numbers which are not gonna be divisible. So it is gonna be 15 minus 4, and the output is gonna be 11. This is the first example they have given out for us, guys. So you can see here the answer they have given, the output is 11. So we'll go to the approach and intuition and approach for solving this question. I'll keep the intuition very simple, guys. I'll keep a very simple intuition. There's no need to focus much on intuition actually. We should count substrings. Substring count divisible by how? Divisible by last non-zero digit. Non-zero. Now, if the last non-zero digit is 1, then the answer is gonna be all the numbers. All the numbers are divisible. Now, what are the key observations here? A key observation. A substring ending in digit D must be divisible. Substring ending in D, end in D must be divisible by D. This is our first point. Our second point, single digit substring except 0, single substring. All single, they have automatically in. This is a group of, what do you say, all the single people. It's a party for singles. So all the singles are like in. Single substance counted. Singles free entry, guys. No. The third step, Instead of all substrings, what we'll do is we'll use modular arithmetic here, mod arithmetic. Instead of taking all the substrings. Now we'll go to the approach. I'll make it very simple. We'll go to the approach. In the approach, the first step. What is the first step? Pre-compute. We'll pre-compute a 2D array, two-dimensional array, which is mods. Why? This mods of ij, right? This counts the substrings ending in current digit, where modulo I is j. Modulo I is j. I wrote the most important point. I didn't write it in detail. This is the first point. Our second point is it is going to help us to track modular calculations. Mod calculations of the for subs of different lengths. For substrings of different lengths. These are first step, guys. Now we'll go to our second step. Very easy step. This is the easiest step of all. We'll just iterate. We'll iterate through the string. We'll iterate through the string, which is S, string S. Now, for this, what are we gonna do? The first step. For each digit C, we'll update counts. C for count of each divisor I of each divisor I from 0 to 9. Now, the second point. New list will create a new list, new count. We'll create another one new list to store updated values. Store updated values. Every substring which is ending in C, C contributes, C will contribute to modulo D. D equal to 0 using the previous mods. Using previous values of okay previous values in mod previous module values in mod I mod I. Okay, this is small m. mod size. Now, the final step in our approach is the last step will update result. Oh shit, result spelling mistake. Sorry. Update result with valid substring. With valid with valid substance. For this, what we are gonna do is our function, our this one. You took mods, right? Mods of okay. There's not sigma int c and zero. Use substrings. This is the formula. Substrings. I mean formula. This is not the formula. This is how we are gonna get the substrings, the valid substrings, where mod modulo d is equal to 0, which implies that it's divisible. So guys, now we'll move on to the next thing. We'll go to the code. A very simple code for this. 10 lines of code, guys. Other than initial line, it's just 6 to 7 lines of code. First, defining the given function solution, defining the given function substance, which returns integer as the output. Return type is integer. Now, this is all initializing 2D array, sorry, 2D list. Mod size. Now, for final count, this is for the final count. In this initialization part, we'll just leave it, no issues. For CNS, what is C? For count in string S, we'll traverse the string. Each digit. We'll, we'll just traverse the whole string. Just writing details so that everyone can understand it. For I in range 0 to 9, which is for I in range 1 to 10. So guys, 1 to 10 because the number says 0 to 9, that's all. We can't divide a number by 0. So like anything, any number divided by 0 is gonna give us 0 only. So yeah, except 0. 0 by 0 is infinity. So with this, we'll take 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is okay. Where is the hash? 1 to 9. Now, second thing is a temporary list. Temp list to store updated counts, new mod count, new mod count. Next, new counts. It's just the given thing. This is the singles. This is the singles enjoying, singles chilling. Now for J in range height. What is this for J in range height? Previous value count update. update pre-value count. Now, new counts j into 10. Now, after this, mods of I equal to new counts. What is this? We'll update, again update mods for next iteration. Result plus equal to this valid strings, valid substrings, ending at given digit. This particular digit. Now, final result. This is our final result. Total, total substrings. Now we are gonna run this code and check. It's accepted, so we'll submit the code. We'll see if it works for the hidden cases as well. And well, so guys, this is gonna work perfectly well for all the given cases, and it's accepted. So with this, we are gonna end our third question also. No, before ending the third question, we can't forget this major step. What is the time complexity and what is the space complexity? Well, okay, I'll say the space complexity first. It's very easy, space complexity. I want the chat by then to say me what is the time complexity. Come on, chat, right? This is a very easy stuff. Time complexity of this is easiest. Now we'll see. What is the space complexity? The space complexity is O of 10 into 10, which is O of 100, which is nothing but O of 1 constant. Because array is fixed. Array fixed 10 into 10. This mod array. Mod array fixed 10 into 10. So anyone in the chat now, even if you answer this, I'm gonna pin you guys to the chat. Let's go chat, right? What is gonna be its time complexity? Very easy question. Go chat. Very easy. Come on. Okay, fine. Time complexity of this is gonna be O of 10 into n, which is equal to O of n. The outer loop will iterate over each character. Outer loop, each character n, each character n, and inner loop at most 9, max 9. So it's a constant. With this, we are gonna end our third question. Anyone has any doubts, guys? I hope there are no doubts. With this, we'll finally go to our fourth question of today. What seems hard, but again, as I say, 5 lines of code is all we need. Okay, we'll go to our final question of the day. Maximize the minimum game score. Okay. We have to maximize the minimum game score. We'll see what this is. We are given an array points of size n and an integer m. There is another array game score of size n where game score I represent the score achieved at ith game. Initially, game score I is equal to 0 for all I. Your start at index -1, which is outside the array, before the first position at index 0. You can make at most m moves. In each move, you can either increase index by 1 and add points I to game score I, or decrease index by 1 and add points to game score I. Note, index must always remain within the bounds of array after first move. So we have to return maximum possible minimum value in game score after at most m moves. Now we'll see the example. Points is equal to 2, 4 and m is equal to 3. So the maximum times we can move is 3. Now we have to return the maximum possible minimum configurations. So for that, what are we gonna do? Initially index I is equal to -1 and the game score will be 0, 0. Now if we increase I, index 0, so the game score will be 2, 0. Next, if we increase I, if we increase I index 1, it's gonna be what, guys? It's gonna be 2, 4. Sorry, 0, it's gonna be 2, 4. Yeah. And if we decrease I, it's gonna be index is gonna be 0 and the value is gonna be 4, 4. So the minimum value in game score is 4. The maximum possible minimum configurations is 4. Now we'll see the constraints. The point's length is in the range of 5 into 10 power 2 to 5 into 10 power 4, including both. The indexing of points is between the range 1 to 10 power 6, including both. And for m, it's between 1 to 10 power 9, including both. So with this, we are gonna jump into solving this question. I guess you're all clear with the question. With this, we are gonna solve the last question of the day. What is the approach, guys? It seems a bit tricky, but what is the approach, guys? So the intuition first, guys. We'll go quick. It's already a lot of time. So intuition first. The intuition is gonna be we have to maximize min value, minimum value in game score. Maximum value in game score after making after after M moves. To achieve this, we are going to use a very important and very easy to thing, which is binary search. Here we'll search mid value mn, mid value of mn. Then we'll check if it's feasible. Next, feasibility check, requirement analysis things. Feasibility. Feasibility check. What is feasibility check? If minimum score of at least mn is attainable or achievable for all positions using utmost moves, which is m. Now, after this, we are gonna go for our approach. The approach. First step, very important, binary search. Okay, Chad, I'll ask you a question. What will be the time complexity of binary search? Anyone in the chat, what is gonna be the time complexity of binary search? Not binaries. It's just binary search. What is gonna be time complexity? Okay, chat. By the time you answer me, I'll continue the question. What is the time complexity of binary search is what I've asked you guys. Now, to set up this binary search, what we'll do? Define search space. Smallest possible minimum score. We'll take it as L. Lowest is equal to 0 and R is equal to max of A into M plus 2. This is R. R. So, next step, within this step, find largest possible MN. Largest possible MN such that it is achievable within M moves. M moves. This is small m. I'm writing it capital M here for now. Now, our first thing is okay. Now, our second thing, feasibility. Feasibility check. For this, we'll define a OK function. We'll define a OK function. The first step here is the first step here is given mn Mn is given. It looks like Mn. Mn is given. Whether it's possible to ensure game score I at least Mn, at least Mn within M moves. Within M moves possible. We'll check this. Is this possible? We wanna check if this is possible or not. After this, the second point. We'll iterate over the array. Iterate array over array. Iterate over array and calculate how many times we need to land on index to, to accumulate at least mn points. To get, I'll just write get m n points. After this, the third point is will execute. Okay, if required moves are within m, within m means will return true. If not, else will return false. Now, the third step in our approach, the third step, binary search execution. Tha- Binary search execution will perform the binary search, perform binary search on mn values. If value is feasible, if value feasible, which is okay, mid, return true. If this happens, what we'll do is we'll move to right. We'll move to right. L is equal to mid. Now, after this, if not, it's if else, move to left, move left. R is equal to mid minus 1. This is R. With this, our binary search is executed properly. And once it's done, we are going to get our final step 4, final answer. Final answer. Now, after binary search BS done, it means now L is having our answer. L has answer. Now, guys, we'll go to the coding part. Again, a very big question, a very big explanation, but 5 lines of code, maybe 10 lines of code for us. Yeah, it's a big thing. So, guys, here the first part, class solution and define Maxwell with return typing, which is all given. This is all declarations. Here, if A is a string, if moves are lesser than length of A, moves less than length of A will return after this. The next step, this lower bound for binary. This and all I won't write. Lower bound for binary search. There's a feasibility function. Feasibility function. You all know what is the feasibility function. I've explained it till now, guys. This is again declaration, current available, and this is for moves required, moves used. So this is minimum times we can land on X. This minimum times we can land at index I. Now, if need is smaller than current, if already we have enough moves, we'll continue. If enough moves, if enough moves, then continue. If not, if we already have enough moves, if not, next result plus equal to 1. We'll move it result just by incrementing 1. Result is equal to result plus 1, which is result plus equal to 1. shorthand writing. Next, result is the sorry, current is equal to 0. We'll reset the steps. Now, else, if not, when extra landings required, extra landing required, result plus is equal to, which is result is equal to result plus 2 into W minus 1, which is double moves. Current is equal to W minus 1, which is remaining moves available. And now finally we'll check if it is within allowed moves. Now, thus for binary search, this is for binary search, and this is my calculating. Everyone knows how to implement binary search. OKML. OKML means check possible. Check if possible. Check if possible. L equal to mid. Move to right. Else move to left. Yes, yes. Move to right means move to right is nothing but will increase will increase possible minimum score. If not, will decrease min score, not min score. Left half. Okay, that's right half. I'll write it so that people won't get confused. Okay, done. Return L max possible minimum value in exact exactly copy. I'll just wait for change, guys. Wait, really, it's not possible. I would have copy pasted the question itself here. Now we'll run this for the sample test cases. So chat, by the time I run and execute it, try calculating its time complexity. It's accepted for the given test cases. Now after submitting it, it runs perfectly well for all the hidden test cases also. Now with this, we are gonna go for the final step, finding the time complexity and the space complexity. Time complexity and the space complexity. First, we'll find its space complexity. Space complexity is great, guys. We'll first find the space complexity, which is gonna be O of one. Only a few extra spaces are used. Few extra spaces used, and there's no additional data structures allotted. No, no additional DS allocated. Okay, that's not OS. It's DS. OS is when I say DS allocated. Now, after space complexity, we are gonna go for time complexity. Anyone in the chat? Okay, no one in the chat, so no one said the answer, so let me go for the answer. Now, so binary search on MN. Binary search on MN. So for this, the search space is from 0 to maximum of A into M plus 2. So, binary search space, log of whatever it is gonna be O of log of max A into M. Now, after this, the next step, feasibility function. Feasibility function runs for O of n time complexity for function feasibility function. This for feasibility function. Now the total time complexity of this O of n big O of n log max A into M. So this is gonna be a final time complexity, guys. With this, we are gonna end today's live stream. If if nobody has any doubts in the chat. So with this, after this, we're gonna meet tomorrow probably with another playlist which is going on. DSA 0 to Pro within 75 questions. You'll be a master of DSA. You'll be a master of data structures and algorithms. You'll be able to give a lot of contests, everything. So we might possibly do that stream tomorrow. Hope so, hopefully. So for today's stream, that's all, guys. Thanks for tuning in. A special shout out to Shanmukesh who tried to give answers for a lot of questions. A few were correct and a few were wrong, but still, it was a good try. Thank you guys for everyone who tuned in. Please like, share, and subscribe. Like the live stream, share it to many people, share the channel so that a lot of people will be getting use of this. And then subscribe to the channel, increase the subscribers count. Thanks for everyone who tuned in. Bye bye, guys.